sophisticated single-page applications, SPAs, when combined with modern tooling and supporting libraries. Vue.js focuses on the view model layer of the MVVM pattern. It facilitates the connection between the view, HTML, and the model, JavaScript, through a reactive and composable data binding system. This means that when the model state changes, the view updates automatically and vice versa, making the development of interactive applications straightforward and efficient. Why use Vue? Vue.js is a progressive JavaScript framework used for building user interfaces and single-page applications. It is designed to be incrementally adoptable. The core library focuses on the view layer only, and it's easy to pick up and integrate with other libraries or existing projects. Vue is also perfectly capable of powering sophisticated single-page applications when used in combination with modern tooling and supporting libraries. Vue is favored for its simplicity, detailed documentation, and a gentle learning curve. It enhances the development process with its reactive data binding and composable components, making it much easier to develop complex applications. The framework's focus on the view model approach of the MVVM pattern facilitates two-way data binding, allowing automatic updates between the model and Vue. Additionally, Vue's ecosystem, including tools like Vuex for state management and Vue Router for navigation, provides everything developers need to build complex applications efficiently. Vue versus other frameworks, React, Angular. Vue, React, and Angular are three of the most popular front-end development frameworks libraries. Each has its unique approach to component-based architecture, reactivity, and state management, making the choice highly dependent on the project requirements and developer preference. Vue is designed from the ground up to be incrementally adoptable. The core library focuses on the view layer only, making Vue easier to pick up and integrate with other libraries or existing projects. Vue is also perfectly capable of powering sophisticated single-page applications when used in combination with modern tooling and supporting libraries. React, developed by Facebook, emphasizes a virtual DOM model for reactivity and encourages the development of reusable UI components. Angular, maintained by Google, is a full-fledged MVC framework that provides a strong opinion on the structure and development process of applications, often leading to higher initial learning curve compared to Vue or React. Setting up a Vue environment. To start working with Vue.js, you can use a CDN, Vue CLI, or a package manager like npm. For simplicity and ease of getting started, we'll use the Vue.js CDN. This setup allows you to include Vue in your project without the need for build tools. In the provided code snippet, we first include Vue.js by linking to its CDN in a script tag. This makes Vue available in our HTML file. We then define a div with an ID of app, which will be our mount point for the Vue app. Following that, another script tag is used to create and mount a new Vue application. Inside this Vue application, we define a data property returning an object that contains a message. Vue's reactivity system will ensure that whenever this message changes, the DOM will be automatically updated to reflect the new state. Vue CLI. Vue CLI is a powerful tool created by Vue.js developers to help streamline the process of developing Vue applications. It provides a full system for rapid Vue.js development, including project scaffolding, development tools, and build processes. Let's demonstrate how to install Vue CLI and create a new Vue.js project. First, we install Vue CLI globally using npm, enabling access to the Vue command in your terminal. Then, we use the Vue create command followed by the project name, here, my Vue app, to scaffold a new Vue.js project. This process involves selecting presets, default setup or manually selected features for your project, such as Babel, ESLint, etc. Once completed, you have a fully set up Vue.js application structure ready for development. Vue DevTools. Vue DevTools is a browser extension available for Chrome and Firefox that provides a comprehensive interface to debug and inspect your Vue.js applications. It allows you to explore the state and component hierarchy of your app, track custom events, and monitor performance, among other features. It's an indispensable tool for Vue.js development. While Vue DevTools cannot be demonstrated through a code snippet because it's a browser extension, once installed, you can easily access it by opening your browser's developer tools. There, you'll find a new tab labeled View, which, when selected, will display information about your Vue app. You can then navigate through your app's components, observe their current state and properties, track events, and much more. It significantly simplifies the debugging process, making it easier to identify and fix issues within your Vue applications. The Vue instance. At the heart of every Vue application is the Vue instance. It serves as the starting point of your Vue application and holds the initial data and options. The Vue instance binds to a DOM element and manages its data, methods, and everything else necessary for the component to function. In this code, a new Vue instance is created and assigned to the variable VM. The L option specifies the DOM element to which the Vue instance will bind, in this case, an element with the ID app. The data option contains the initial data for the Vue instance, which includes a message property. This setup allows the Vue application to be reactive. Changes to the message will automatically update any bindings in the #app element without further JavaScript manipulation. Data and methods. In Vue, data and methods are essential for building dynamic and interactive applications. The data option is used to declare reactive properties that can be used in your application's template. Methods, on the other hand, are functions that can be invoked in response to events or data changes. In the provided code, we have a Vue instance targeting an element with the ID app. The data object contains a property named message, initialized with hello, Vue. This message can be displayed and updated dynamically across the application. Additionally, there's a method called reverse message, defined under the methods option. This method reverses the message string when called. The this keyword within methods references the Vue instance itself, allowing access to instance properties and methods. Computed properties and watchers. Computed properties are used to declare reactive properties based on other data properties in a Vue instance. They are cached and only reevaluate when one of their dependencies changes, making them efficient for operations that might be expensive to run on every update. In this example, reversed message is a computed property that depends on the message data property. It reverses the string contained in message. Since reversed message is computed, it updates automatically and efficiently whenever message is modified, without needing explicit instructions to do so. Class and style bindings. Class and style bindings in Vue.js offer a powerful way to dynamically assign CSS classes and inline styles to your components based on the state of your application data. This allows for more interactive and responsive designs without cluttering your HTML with conditional logic. This code snippet demonstrates how to bind the class names active and TextDanger based on the component's data properties isActive and hasError. The syntax class equals active is active, TextDanger hasError dynamically assigns these classes. If isActive is true, the active class is applied, and if hasError is true, the TextDanger class gets applied. This approach keeps your template clean and emphasizes the reactive connection between UI and state. Conditional rendering. Conditional rendering in Vue allows components or elements to be rendered based on a specific condition. This is useful for creating dynamic interfaces that change to reflect the application state. Vue provides directives such as vif, velsif, velse, and vshow to manage conditional rendering. In the provided example, we define a Vue component with a data property isLoggedIn, which is initially set to false. Within the template, we use the vif directive to conditionally render the message welcome back if isLoggedIn is true. If isLoggedIn is false, the velse directive instructs Vue to render please log in instead. This setup allows the component to dynamically display content based on the user's login status. List rendering. In Vue.js, list rendering is a fundamental concept that allows you to render a list of items dynamically based on an array. It's achieved using the v-for directive. This makes it straightforward to display an array of data on the page and manage the display as the data changes. Let's look at a basic example where we render a list of items from an array. In this example, we have an array called items, containing objects with ID and message properties. The v-for directive in the li tag iterates over each item in the items array. The key attribute is used to provide a unique key for each element in the list, which helps Vue manage the DOM efficiently, especially during updates. The text inside item message interpolates the message property of each item, displaying it within the list item. This structure dynamically creates a list in the DOM corresponding to our array's contents. Event handling. In Vue, event handling is managed through the v-on directive, or the shorthand @ symbol. This directive allows you to listen to DOM events and execute some JavaScript when they occur. This is essential for responding to user inputs and actions like clicks, form submissions, and key presses. In the code example, a button element uses the v-on click directive to register a click event listener. The value assigned to v-on click is a method named greet. When the button is clicked, the greet method is executed, which triggers an alert displaying "Hello Vue." This illustrates how Vue handles user-initiated events to invoke corresponding JavaScript functions. Form input bindings. In Vue, form input bindings use the vModel directive to create two-way bindings on form input, text area, and select elements. This means that when the input value changes, the bound data on your Vue instance updates automatically. In the provided code snippet, we have an input element using the vModel directive to bind its value to the message property on the component's data object. As a user types into the input field, the value of message updates in real time, demonstrated by the text interpolation in "the message is message." This illustrates two-way data binding, where data updates affect the UI, and UI changes update the data. Component basics. In Vue, components are reusable Vue instances with a name. They help in creating custom elements that you can use in your Vue applications. This modular approach makes it easier to build and maintain complex interfaces. Let's explore the basics of defining and using a simple Vue component. The code snippet defines a Vue component with a button that, when clicked, increments a counter. The component structure is divided into a template and a script. The template section contains HTML code that defines the component's structure, including a button that displays the current count. The script section with export default contains the component's logic, defined as a JavaScript object. This object includes a data function that returns an object with a count property initialized to 0. This property is reactive, meaning Vue automatically updates the DOM when count changes. Component registration. In Vue, components can be registered globally or locally, allowing them to be reused across your application. Global registration makes a component available in any new Vue instance, while local registration scopes the component availability to where it's registered. In this code snippet, my component name is registered globally using Vue.component, where the first parameter is the component's name, and the second parameter defines the component options, such as its template. Once registered, my component name can be used as a custom element inside any Vue instances. Props. In Vue, props are custom attributes you can register on a component. When a value is passed to a prop attribute, it becomes a property on that component instance. This feature is utilized for passing data from parent components to child components. In this code snippet, child component is a child component inside a parent component's template. The parent passes a piece of data from parent to the child component through a prop named custom prop. This prop is registered in the child component with the props custom prop syntax. Inside child component, custom prop is used to display the value passed through the prop, demonstrating simple parent-to-child data flow using props in Vue. Custom events. In Vue, components can communicate up to their parent components using custom events. This allows child components to emit an event that the parent component can listen to. Custom events are essential for passing information from child components back up to their parent. In the provided code, a Vue component includes a button that, when clicked, emits a custom event named custom event using the emit method. The second argument, someData, represents the data passed with the event. To listen to this event, the parent component would use v-on custom event or @custom event in the template where this component is used, allowing the parent to react to the event, such as by updating its data or invoking methods in response. Slots. Vue slots are a powerful feature that allows content to be distributed in the template of a component. This means you can inject content into a component from its parent, making the component more versatile and reusable. In this example, we'll create a simple alert box component that uses a slot to allow custom content to be inserted into it. Here, slot default alert message slot is used within the alert box component. The slot tag specifies where the parent content should be displayed. If the parent component does not provide any content, the default text, default alert message, will be shown. This approach lets you create flexible components that can be reused in different contexts with customized content. Dynamic and async components. Vue.js provides powerful options to dynamically switch between components and to load components on demand, asynchronously, enhancing performance in large-scale applications. Dynamic components with component tag and async components using dynamic import can achieve this. The component tag with is attribute in Vue allows for switching between multiple components within the same mount point, controlled by the current component data property. The component to display can change dynamically based on application state or user actions. Async components, on the other hand, leverage JavaScript's dynamic imports. By passing a function returning an import statement to Vue.component, Vue will only load the component when it's required for rendering. This reduces the initial load time by splitting the bundle into chunks and loading them when necessary. Component lifecycle hooks. In Vue, each component goes through a series of steps in its lifecycle, from creation to destruction. Vue provides lifecycle hooks that allow you to execute code at specific stages. Understanding these hooks is crucial for tasks like making API calls at the right time or performing cleanups before a component is destroyed. The code exemplifies Vue's lifecycle hooks by adding console logs to observe when each hook fires. Initially, before create and created hooks run when the component is initialized, before and after it's created, respectively. Then, before and after the component is added to the DOM, before mount and mounted hooks fire. When the component updates due to data changes, before update and updated hooks are executed. Finally, when the component is about to be removed from the DOM, before unmount and unmounted come into play. This mechanism is vital for managing resources and optimizing application performance. Component communication: parent-child, child-parent, non-parent-child. In Vue, a parent component can send data to a child component using props. Here's how to pass a message from a parent to a child component. In this example, the parent component communicates with the child component by passing a message prop to the child component. The message prop is bound to the parent message data property of the parent component. This showcases a basic parent-to-child communication pattern. Provide inject. In Vue, the provide inject feature is a mechanism to pass data from an ancestor component to its all descendant components, regardless of how deep they are, without having to manually pass props down at every level. This is especially useful for deeply nested components, or when certain pieces of state need to be accessed by many components within an application. In the example, the ancestor component provides a value named shared value, which contains a string. The child component, which could be deeply nested within the ancestor or just directly inside of it, injects shared value. By injecting shared value, the child component gains access to the value provided by the ancestor, allowing it to display "Hello from ancestor." This eliminates the need for prop drilling, passing props through intermediate components when attempting to share data between distant components. Component libraries and UI frameworks. Vue.js is not just great for building your custom components, it also plays well with a wide range of component libraries and UI frameworks. These libraries provide pre-built components like buttons, modals, and grids that can help speed up the development process by avoiding reinvention of the wheel. Let's look at how to use a component from a popular UI library called Vuetify. In the code snippet, we first import Vue and Vuetify along with Vuetify's CSS file. By calling Vue.use Vuetify, we tell Vue to use Vuetify as a plugin, making Vuetify's components available throughout our application. We then create a new Vue instance, specifying Vuetify new Vuetify, which initializes Vuetify with its default settings. This setup allows us to start using Vuetify's components in our Vue app immediately. vbind. In Vue, the vbind directive is used to bind an attribute to an expression. This allows dynamic updates to HTML attributes such as ID, class, style, and custom component props. By using vbind, the value of the attribute can change whenever the bound data changes, without the need to manually manipulate the DOM. In the given code, vbind class binds the class attribute to an object expressing which classes to add based on certain conditions. Here, the class active is added to the div element if isActive is truthy. This showcases the power of vbind in dynamically updating classes based on the component's data properties or computed properties. This pattern is extremely useful for adding and removing classes based on the state of a Vue instance. vModel. The vModel directive in Vue.js is used to create two-way data bindings on form inputs, text areas, and select elements. It automatically picks the correct way to update the element based on the input type. This makes it easier to incorporate interactive data-driven forms in your application. In the provided code sample, the vModel directive binds the input element to the message property on the instance's data object. Any changes to the input's value will immediately update the message property, and any changes to the message property will update the input's value. This two-way binding simplifies handling user input in forms by eliminating the need for manual event listeners and state updates. v-for. The v-for directive in Vue is used to render a list of items by iterating over an array or object. It's one of the fundamental directives for handling dynamic content. This example demonstrates how to use v-for to display a list of items from an array. In this snippet, UL and li HTML elements are used to create a list. The v-for directive is applied to the li element, indicating that for each item in the items array, an li element should be rendered. The key is used to provide a unique key for each item, which is essential for Vue's rendering system to identify each node uniquely. Inside the li tags, the item's message property is displayed using the double curly braces syntax. The script part provides the component's data, including the items array, which contains objects each with an ID and a message. vif, velse if, velse. In Vue, conditional rendering is handled using the vif, velse if, and velse directives. These directives allow you to conditionally render elements or component templates based on the truthiness of expressions. They work similarly to if-else statements in traditional programming languages. In the provided example, 3 paragraphs are conditionally rendered based on the value of the type data property. The first paragraph will only display if type is exactly A. If type is B, the second paragraph is shown due to the velse if directive. For any other value of type, the third paragraph, which follows the velse directive, is displayed. This approach allows for selectively rendering content based on complex conditions without cluttering the template with multiple vif directives. von. The von directive is used to attach event listeners to elements in Vue templates. It allows you to listen for specific events, like clicks, input changes, and more, then execute some JavaScript code when those events occur. It's an essential part of making your app interactive. In this example, the von click directive is attached to a button element. When the button is clicked, the greet method is called. The greet method is defined within the component's methods object, and it shows an alert saying, "Hello Vue." This is a straightforward way to add interactive behavior to your Vue components. vshow. The vshow directive in Vue.js is used to conditionally toggle the display of an element. Unlike vif, vshow does not remove the element from the DOM. It simply toggles the CSS display property of the element based on the truthiness of the expression provided to vshow. In this example, a div element will be visible or hidden based on the value of isVisible. When isVisible is true, the div will be displayed. If isVisible becomes false, the div's display property is set to none, hiding it without removing it from the DOM. The advantage of using vshow over vif is performance, particularly for elements that toggle frequently, as altering CSS is cheaper than adding removing DOM elements. vpre. The vpre directive in Vue is used to skip compilation for this element and all its children. It's particularly handy when you have raw mustache tags inside the HTML that you don't want Vue to compile, or when optimizing performance by skipping unnecessary compilation for certain parts of the template. In this example, vpre is applied to a div element, which tells Vue to skip all compilation for the content inside this div. This means that the mustache tag, this will not be compiled by Vue, will be rendered as is, without Vue attempting to evaluate it as an expression. This can be useful when displaying raw template syntax to users, or when optimizing parts of large applications. vcloak. The vcloak directive in Vue.js is used to keep an element and its children hidden until the Vue instance is fully mounted and ready. This prevents users from seeing uncompiled mustache bindings when the page is loading. In the provided code, the vcloak directive is applied to a div element that contains a mustache binding to display message. The accompanying style tag uses a CSS attribute selector to target elements with vcloak and set their display to none. This effectively hides the element until Vue has rendered all bindings. When Vue is ready, it removes the vcloak attribute, allowing the CSS rule to no longer match, and the element becomes visible with all bindings properly compiled, preventing flashes of raw template syntax to users. Vueonce. The Vueonce directive in Vue is a special directive used to render plain HTML elements or component elements only once. When an element is marked with Vueonce, Vue will render its content once and skip any future updates to it. This is especially useful for optimizing performance by reducing the number of updates Vue needs to perform in components or parts of the template that are static or will not change. In the provided example, a div element is used with the Vueonce directive. It contains a message that is interpolated within it. The Vueonce directive tells Vue to render this element and its content only once, ignoring any future updates to the message reactive property. This means, even if the value of message changes later on, the content of this div will remain the same as it was during its initial rendering. This can significantly improve performance in large applications where certain content does not need to be reactive. Setting up Router. To use Vue Router, firstly, you need to install it. Assuming you're using Vue CLI, Vue Router can be added during project setup or added later via npm or yarn. After installation, you have to set up the router by importing it into your main.js file, defining your routes, and then creating a new Vue Router instance with those routes. This code snippet demonstrates the basic setup for Vue Router. Vue.use Vue Router tells Vue to use the router. The routes array contains objects that map paths to components. Here, the path / is mapped to a home component. The Vue Router instance is created with these routes and a history mode, allowing for pretty URLs without hashes. Finally, the router is passed to the Vue instance during its creation, so Vue knows to use this router setup. This is typically done in the main.js file of a Vue project. Route configuration. Route configuration is a fundamental concept in Vue Router, essential for defining paths and their corresponding components. This setup enables your application to navigate between different components based on the URL path accessed in the browser. Let's look at a basic example of how to configure routes in a Vue application. In this code, we first create a new instance of Vue Router and pass it a routes option. This option is an array where each element is an object that represents a route. Each route object must have at least two properties: path, specifying the URL path, and component, specifying the component to render when the path is accessed. In the example, navigating to /home will render the home component, and navigating to /about will render the about component. This is the foundation of creating a single-page application, SPA, with Vue. Programmatic navigation. Programmatic navigation is a method that allows you to navigate between pages without the need for the user to click on a link. This is achieved by using Vue Router's methods such as push, replace, go, etc. directly in your Vue components. In the code example, this.router.push path about is used to programmatically navigate to the /about page. The push method adds a new entry in the browser's history stack, allowing you to navigate back. This method is similar to clicking and router link to /about. It's very useful for navigating after an action like submitting a form or clicking a button that doesn't directly encapsulate a hyperlink. Nested routes. Nested routes in Vue Router allow for the creation of hierarchical page structures. This feature is particularly useful for creating subpages within an application, such as a user profile with different sections. To define nested routes, specify children routes within a parent route in the Vue Router configuration. In this code, user is defined as a route with two nested routes, /user profile and Vue posts. Each nested route is defined within the children array of the parent route. The path for each child route is relative to the parent route's path. When navigating to user profile or user posts, the user component would be rendered along with the respective child component, user profile or user posts. This setup allows for organizing components into a nested structure, which can make managing complex page layouts easier and more structured. Dynamic routes. In Vue Router, dynamic routes allow you to pass parameters within the URL, making your application adaptable to showing different content based on parameter values. Dynamic routes are essential for user profiles, product details pages, and any scenario where you need to display specific information based on the given identifier. In the code above, ID is a dynamic segment within the URL path for the user route. When a user navigates to /user/1, the Vue Router matches this URL to the user route, treating 1 as the value of the ID parameter. The router then loads the user component, where you can access this ID parameter via this $route.params.id to fetch and display the user's information dynamically. This approach enables the application to reuse the same component template for different users by simply changing the URL parameter. Route guards. Route guards in Vue Router are essential for controlling access to routes based on specific conditions. They can be used for authenticating a user before they access a certain route, redirecting, or even preventing access if the conditions are not met. There are several types of guards, such as global, per route, or in-component guards. We'll focus on a simple global before each guard that checks if a user is authenticated. In this code snippet, we define a global before each route guard using the router instance. The guard checks each navigation attempt before it happens. The function receives 3 arguments: to, destination route, from, source route, and next, a function that, when called, resolves the hook and allows the navigation. The guard examines if the route being navigated to contains a meta field requires auth, that is true, and if the user isn't authenticated, auth.isLoggedIn. If both conditions are met, the user is redirected to a /login page using next/login. Otherwise, the navigation proceeds as normal with next. Lazy loading. Lazy loading is a design pattern to defer the loading of resources until they are actually needed, improving the performance of your application. In the context of Vue Router, it allows us to load component assets only when a particular route is visited, making the initial load of the app faster. In this example, the user component is only loaded when the user navigates to the /user/ID route. This is achieved by using a dynamic import components user.vue within the route configuration. Instead of loading all route components at the start, each component is fetched the first time the route is accessed, reducing the initial load time and bandwidth usage. Vue Router hooks. Vue Router hooks, also known as navigation guards, are functions that allow you to hook into the routing process at various stages. They can be global, per route, or in-component, giving you control over the navigation. These hooks are essential for tasks like authentication, logging, or async data fetching before entering a route. In this example, a global before guard is defined using router.beforeEach. This guard checks if the target route to, or any of its parents requires authentication, requires auth meta field. If authentication is needed and the user is not authenticated, is authenticated is false, the navigation is redirected to the login page /login. If the user is authenticated or the route does not require authentication, the navigation proceeds using next. Next is a function that must be called to resolve the hook. Failing to call it will halt the navigation indefinitely. Why state management? In Vue applications, managing state can become challenging as your application grows. Components need to share and react to reactive data, users, preferences, etc. Vuex serves as a centralized store for all the components in an application, enabling them to access and react to shared state efficiently. It provides a unified way to manage state that is outside the scope of any individual component, ensuring data consistency and simplifying state management across large applications. State management solves the problem of prop drilling, where data needs to be passed through multiple layers of components. It also addresses the issue of maintaining sync across various components that rely on the same state. By using Vuex, you create a single source of truth for your app's state, making data management more predictable and debugging easier. It provides mechanisms such as mutations for state changes, actions for asynchronous operations, and getters for accessing state, ensuring a well-organized and efficient system for state management within Vue apps. Integrating Vuex in a Vue app. To integrate Vuex in a Vue app, first you need to install Vuex, followed by creating a store. The store is where you define the state, mutations, actions, and getters. This store will then be injected into the main Vue instance, making it accessible across your entire app. In this example, after importing Vue and Vuex, Vuex is activated with Vue.use Vuex. A store is created using new Vuex.store, where you define the initial state, count 0, and mutations increment to modify the state. The store is then passed to the Vue instance via the store option. Within the Vue instance, you can access the store methods such as committing a mutation with this store.commit increment, which modifies the global state. This setup enables state management across your Vue app, allowing components to reactively update when the state changes. State getters. In Vuex, state is the single source of truth for your application's status. This means all your application's shared data resides here, making it easy to reason about your app. This piece of code sets up a basic Vuex store with a single state property count. The state is an object where you define all the data your application needs. Here, count is initialized with a value of 0. Mutations, actions. In Vuex, mutations are responsible for synchronously changing the state, while actions commit mutations and can contain asynchronous operations. Let's explore a simple example where we increment a counter. In the provided code, the Vuex store is defined with a state object containing a count property. The increment mutation directly modifies the count state by increasing it. To handle asynchronous operations, an action named increment_async is defined. This action waits for 1 second, using setTimeout, then commits the increment mutation. Use actions to dispatch mutations when dealing with asynchronous or time-consuming tasks. Modules. As a Vuex store grows in a complex application, it can become cluttered if you try to manage all your state in a single giant object. Vuex allows us to divide our store into modules. Each module can have its own state, mutations, actions, and even nested modules, encapsulating and organizing the parts of your store. In this code, we define a module named Module A, with its own state and a mutation to increment its count state. This module is then registered within a Vuex store under the key A. This allows us to structure our application in a modular fashion, improving readability and maintainability. Namespaced modules. In Vuex, namespaced modules allow for better modularity and encapsulation by providing a way to split the store into multiple modules. Each module can contain its own state, mutations, actions, and getters. When a module is namespaced, all of its getters, actions, and mutations are automatically bound to the module's namespace. This helps to avoid name collisions and makes it easier to work with large Vuex stores. In the provided code, we define a Vuex module named Module A with namespaced true, indicating that this module is namespaced. The state contains a single property count. We also define a mutation increment that increases the count by 1, and an action increment if odd that only commits the increment mutation if the current count is odd. This module is then registered within a Vuex store under the namespace A. To access or trigger the mutation from this module, we use the namespace followed by the mutation name, store.commit a/increment, which demonstrates how namespaced modules help organize and encapsulate Vuex store operations. Using Vuex in components. Vuex enables state management in Vue applications, allowing for shared state across components. When using Vuex in components, you access state, mutations, and actions defined in the Vuex store. This tutorial will demonstrate how to access and modify state within Vue components using Vuex. In the example, map state is used within the computed properties to access the counter state from Vuex. This enables the component to reactively display changes to counter. Map actions is used to bind Vuex actions, increment in this case, to methods within the component, allowing for interactions like incrementing the counter. The method increaseCounter, when called, will execute the increment action defined in the Vuex store, effectively increasing the counter. This setup facilitates a clear separation of concerns, with state management logic housed within Vuex and component logic focused on presentation and user interaction. Vuex patterns and best practices. Using Vuex efficiently requires understanding its core principles and adopting best practices to ensure scalability and maintainability of your application. This example focuses on structuring mutations, actions, and getters to facilitate easy updates and code comprehension. This code snippet illustrates the foundational structure of a Vuex store, showcasing how state, mutations, actions, and getters are defined and interconnected. The state holds the application's state. Mutations are the only way to synchronously change the state, demonstrated by the increment mutation that increases the count state. Actions handle asynchronous operations and commit mutations, with our increment action committing the corresponding mutation. Getters provide a way to derive enhanced information from the state, here calculating double count based on the current count. This architecture separates concerns, making code easier to manage and understand. Mixins, basics to advanced. Mixins in Vue are a powerful feature to distribute reusable functionalities among Vue components. They provide a way to create reusable code snippets that can be injected into Vue components. This avoids code duplication and enhances modularity. In this example, a global mixin is created using Vue create app mixin. The created lifecycle hook in the mixin logs a message when any component in the application is created. This demonstrates how mixins can contribute to the component's lifecycle methods globally. Creating custom directives. Vue allows you to create custom directives to apply reusable functionalities across your components. Custom directives are useful for directly manipulating the DOM, which is sometimes necessary for integrating non-Vue libraries or for custom low-level DOM operations. Let's see how you can create and use a custom directive. In this example, we define a custom directive named focus. The directive has an inserted hook, which is called when the bound element is inserted into the DOM. Inside this hook, we perform the DOM operation el.focus to automatically focus the element. This directive can then be used in any component template by adding vfocus to the element, which will automatically gain focus when it is inserted into the document. Using mixins and custom directives in Vue applications. Mixins in Vue are a powerful feature used to create reusable chunks of code that can be inserted into Vue components. They allow developers to share functionalities across components without having to duplicate code. In this code snippet, we define a mixin named myMixin that includes a lifecycle method created and a method named hello. When a Vue component includes this mixin, by adding it to its mixins array, the component will inherit the hello method, and the created hook from the mixin will be called automatically when the component is created. This demonstrates how mixins can be used to extend the functionality of Vue components. Reactivity basics. In Vue 3, the Composition API introduces a more flexible and organized way to structure your components. A core aspect of this API is its reactivity system. Reactivity in Vue is what makes the framework powerful, allowing you to create dynamic applications with ease. Let's start with the basics of making a reactive state. In this code snippet, we start by importing the reactive function from Vue. We then use it to create a reactive state object. The reactive function takes a plain JavaScript object as an argument and returns a reactive proxy of the same object. In this example, our state consists of a single property count with an initial value of 0. Any changes to count will be automatically detected by Vue, triggering updates in the DOM where count is used. This is the essence of Vue's reactivity system, enabling components to react to changes in state. Ref and reactive. In Vue 3's composition API, ref is used to make a piece of state reactive. When you wrap a value with ref, it becomes a reactive reference to the value. You can then use this reference in your template, and whenever the reference's value changes, Vue will automatically update the DOM. In this code, we use ref to create a reactive state variable count. Notice how we access and update the value of count using count.value. Then we expose count and a method increment that modifies count to the component's template. This makes count reactive. Any updates to it will be reflected in the component. Computed and watch. Computed properties are used in Vue to calculate a value on the fly. They are reactive and cache their value until their dependencies change. Here, we'll create a simple Vue component with a computed property to demonstrate its usage. In the code, first name and last name are reactive states. Full name is a computed property that concatenates first name and last name. When first name or last name changes, full name will automatically update and re-render in the template. Lifecycle hooks in Composition API. In Vue 3's Composition API, lifecycle hooks allow you to perform actions at different stages of a component's lifecycle. Unlike the Options API, where lifecycle hooks are directly integrated into the component's options object, in the Composition API, they are imported as functions from the Vue package and can be used within the setup function. In this code snippet, we import onMounted and onUnmounted from the Vue package, which correspond to the mounted and unmounted lifecycle hooks in the Options API. Inside the setup function, onMounted is called with a callback function that logs a message when the component has finished mounting. Similarly, onUnmounted is called with a callback function that logs a message just before the component is unmounted. This shows how to perform setup and teardown actions in the Composition API using lifecycle hooks. The setup method. In Vue 3's Composition API, the setup method acts as the entry point for the Composition API. It's where you define your reactive state, computed properties, and functions before the component is created. The setup method is called right after the component instance is initialized, but before any other lifecycle hooks, like created or mounted, are invoked. In this code, the setup method is used to declare a reactive reference, count, using the ref function from Vue 3's reactivity system. This makes count a reactive state that can be used and updated within the template or other parts of the component. A function, increment, is also defined within setup, which increments the value of count when called. The return statement at the end of setup exposes the count and increment to the template, allowing them to be used directly within the component's template or other options like methods, computed properties, and watchers. Using Composition API inside Options API. Vue 3 introduces the Composition API as a more flexible and scalable way to organize logic. However, this doesn't mean the Options API is obsolete. In fact, you can seamlessly integrate features from the Composition API within the Options API. This is particularly useful in scenarios where migrating an entire project to the Composition API isn't feasible, or when you want to incrementally adopt the Composition API features. In the provided code example, we import ref from Vue 3's Composition API and utilize it within the setup function of a component defined using the Options API. The setup function is a special method recognized by Vue 3, where Composition API logic can be included within an Options API component. Here, we declare a reactive message variable using ref and return it so it can be used within the component's template. The template then binds to message to display its value. This is a basic demonstration of how to leverage the Composition API's reactive features inside an Options API component. Provide inject in Composition API. The Provide Inject feature in Vue's Composition API enables an advanced pattern for passing data deeply through nested components without the need to pass props manually at every level. This becomes particularly useful in creating a dependency injection mechanism where components far down the tree can access data from their ancestors without relying on the prop chain. In the provided code snippet, we demonstrate the basic use of Provide Inject within the setup function of Vue 3 Composition API components. In the parent component setup function, we declare some data, and use the provide function to make it available to descendant components by associating it with a key, data key. Then, in a descendant component, we use the inject function with the same key to access the provided data. The received data is then made available in the descendants component template. This pattern is invaluable for deep component hierarchies, or when creating a plugin or library that needs to provide some data or functionality to deeply nested components. Composition API Best Practices. The Composition API in Vue 3 provides a flexible way to compose component logic. Adhering to best practices ensures your code is maintainable and scalable. Let's explore some essential tips. 1. Encapsulate logic. Place related reactive states and functions together inside setup to improve readability. 2. Use descriptive names. Choose clear and descriptive names for composition functions and reactive references, like doubled count for a computed value. 3. Expose only what's necessary. Return only the state and functions that need to be accessible outside the component. This keeps the component's public interface clear and concise. 4. Leverage composition functions. Reuse logic across components by extracting it into composition functions. This encourages dry, don't repeat yourself principles and enhances code reusability. Introduction to testing Vue applications. Testing is a crucial part of software development that ensures your application works as expected. With Vue.js, testing can be performed at different levels, including unit tests, which test individual components in isolation, and end-to-end E2E tests, which test the flow of the application as a whole. This introduction will focus on setting up a simple unit test for a Vue component. In this example, we use Vue TestUtils, the official library for testing Vue components. The shallow mount method is used to create a lightweight instance of the myComponent component for testing, without rendering its child components. This allows for faster and more isolated tests. The test checks if the mounted component is indeed a Vue instance, ensuring the correct creation and mounting of the component. This basic test is a good starting point for more complex component testing scenarios. Unit testing with Jest. Unit testing in Vue traditionally involves testing individual components or functions to ensure they operate as intended in isolation. Jest, a popular JavaScript testing framework, can be utilized for this purpose due to its simplicity and fast execution. The following example demonstrates how to test a simple method from a Vue component using Jest. In the given code, we first import shallow mount from @Vue TestUtils and the component we want to test. Shallow mount creates a wrapper that contains the mounted component, which helps us isolate the component and simulate its behavior. We define a test case using test method, where we describe the expected behavior. In this case, that the increment method increments the count property of the component. We mount the component with shallow mount, call increment method on the component's instance via wrapper.vm, and finally, use expect along with to-be matcher to assert that the count property equals 1 after the method call. This illustrates a basic pattern for testing component methods in Vue with Jest. E2E testing with Cypress. End-to-end E2E testing with Cypress provides a powerful way to simulate user interactions on your Vue application, ensuring the app works as expected from a user's perspective. Unlike unit and integration tests, E2E tests interact with your app just like a real user would, by clicking links, filling out forms, and navigating across your site. Here, we'll look at a simple Cypress test that navigates to a Vue application's homepage and verifies the presence of a specific element. This code snippet showcases the basic structure of a Cypress E2E test. First, it wraps the test in a describe block, grouping it under the homepage visit label for clarity. Inside the describe block, there's an it function that contains the actual test, named successfully loads, to indicate its purpose. The cy.visit/ command tells Cypress to start the test by navigating to the root URL of your application, simulating a user landing on the homepage. Finally, the cy.contains welcome to your Vue.js app command checks if the text welcome to your Vue.js app is present on the page, verifying that the homepage loads successfully and displays the expected content. Testing props and custom events. Testing props and custom events in Vue.js components helps ensure that they correctly receive and react to inputs and emit the expected outputs. This is crucial for maintaining robust, predictable components. We'll use Vue test utils to mount a component with props and listen for its custom events. This code snippet demonstrates how to test a Vue.js component by passing props and listening for custom events using Vue test utils. First, we import Vue test utils mount function and the component to test. We then mount the component with props data, simulating the passing of props as we would in a real-world scenario. Next, we trigger a custom event on the component's instance, wrapper.vm, and pass data as its payload. Finally, we verify two things: that the component correctly renders text based on the prop, wrapper.text, to contain hello Vue, and that the custom event was emitted with the expected payload, wrapper.emitted custom event, to equal data. This process ensures that our component behaves as expected when receiving props and emitting events. Testing Vuex and Vue Router. To test Vuex, specifically its actions or mutations, one should isolate the part of the store being tested. This can be done using a mock store or by testing the store directly in a testing environment like Jest. In this example, we're testing a Vuex mutation called increment. Initially, the state count is 0. After the increment mutation is applied, we verify that the state's count is incremented to 1. This approach tests the direct effect of mutations on the state. Code splitting. Code splitting is a technique that enables splitting your codebase into smaller chunks, which can be loaded on demand or in parallel. This improves your app's load time, as users only download the code they need when they need it. In Vue, code splitting can be elegantly handled with Vue Router and Webpack's dynamic import syntax. In the provided code example, we use Webpack's dynamic import syntax to define a component that is only loaded when the user navigates to the /foo route. This is achieved by assigning a function that returns the import call to the component property of the route configuration. Vue Router will automatically handle the rest, loading the component asynchronously when it's needed. This strategy significantly reduces the initial load time of the app by loading only the essential code and fetching other components on demand. Vue internals. Understanding Vue internals is crucial for optimizing Vue applications. This involves knowing how Vue manages reactivity and component rendering. We'll delve into a simplified example to illustrate Vue's reactivity system, which is centered around the observer pattern. In this code, Vue.observable is used to make a plain JavaScript object reactive. When data.count is updated, Vue detects this change and triggers any side effects that are dependent on data.count. Here, Vue.watchEffect is used to register a watcher function, which simply logs the current count. Upon updating data.count, Vue automatically triggers the watcher to rerun, displaying the updated count. This showcases Vue's reactive system at a high level, where dependencies are tracked and watchers are notified about changes. Custom render functions. Vue.js provides an elegant way to directly manipulate the virtual DOM through custom render functions, offering more control and flexibility beyond the use of templates. This approach is particularly useful for complex components or when working with third-party libraries that don't integrate seamlessly with Vue's reactivity system. In this example, a Vue component is defined using a custom render function. The createElement function is used to programmatically generate a tag with an href attribute, which value is obtained from the component's props. The content within the anchor tag this/slots.default allows for slot content, supporting Vue's slot mechanism within custom rendered elements. The key takeaway is how the render function can be leveraged to create tailored DOM elements in a reactive and efficient manner. Server-side rendering, SSR, with Nuxt.js. Server-side rendering, SSR, improves the performance and SEO of your Vue.js applications by rendering them on the server before sending them to the client. Nuxt.js simplifies the process of setting up SSR for Vue apps by providing a higher-level framework that encompasses all the configurations needed for SSR. This command sets up a new Nuxt.js project, which is configured for server-side rendering by default. Nuxt.js takes care of the complex configuration required for SSR, including routing, data fetching, and template rendering, making it easier to develop performant and SEO-friendly Vue.js applications. Static site generation with Vue and Nuxt.js. Static site generation (SSG) is a methodology where websites are generated at build time, resulting in static files for each page. This process enhances performance and security. Nuxt.js, a framework based on Vue.js, provides an easy way to create statically generated sites. Let's explore how to enable SSG using Nuxt.js. The provided code snippet should be placed inside the nuxt.config.js file. By setting the target property to static, you're instructing Nuxt.js to pre-render all pages of the application during the build phase. This generates a static site that can be easily hosted on services like Netlify or GitHub Pages. The key advantage of this approach is the enhanced loading speed for your users, as the server doesn't need to process requests for HTML documents at runtime. Additionally, this can significantly improve your website's SEO and reduce server load. Performance tuning. In Vue, performance tuning is about optimizing your application to reduce load times, improve responsiveness, and efficiently use resources. One common technique involves using Vue's built-in directives and features, like lazy loading components, tracking and minimizing reactivity, and leveraging Vuex wisely. This code snippet demonstrates asynchronous component loading, a performance optimization technique, in Vue. Instead of loading all components up front, which can slow down the app's initial load time, this approach loads a component only when it's needed. By using the dynamic import syntax inside of Vue component registration, you enable the component to be fetched asynchronously. This reduces the initial load time, as smaller bundles are loaded initially, and further components are loaded on demand, enhancing the user experience on bandwidth-constrained environments. Security best practices. Security is crucial for any web application, including those built with Vue.js. Ensuring the security of your Vue application protects it from vulnerabilities such as XSS attacks, CSRF, and more. Vue provides built-in mechanisms to help combat common security threats, but developers must also follow best practices. In the given code, vHTML is used to render raw HTML in the template. While it can be useful, it also opens up the application to cross-site scripting, XSS attacks, if user input comes from an untrusted source. A best practice to follow here is to always sanitize any user input before rendering it, or better yet, avoid using vHTML with user-generated content altogether. Instead, use vtext for plain text to automatically escape HTML and protect against XSS. Production build setup. When you're ready to deploy your Vue application, it is crucial to prepare a production build that is optimized for performance. This involves various steps including minification, optimization, and setting environment variables. Let's examine how to set up a Vue project for production using Vue CLI. The command Vue CLI service build is executed in the terminal within your Vue project directory. It triggers the build process that compiles your application into static files ready for production. This process includes minifying your HTML, CSS, and JavaScript files to reduce file size, optimizing your code, and splitting it into smaller chunks for faster loading times. The output is saved in a distlaf directory, which you can then deploy to your hosting server. This step is pivotal in ensuring that your application runs efficiently when accessed by users. Deploying to Netlify. Netlify offers a simple and powerful way to deploy Vue applications. It connects directly to your Git repository for continuous deployment. Here, you'll learn the basic steps to prepare and deploy your Vue app to Netlify. To deploy a Vue application to Netlify, start by pushing your code to a Git repository, GitHub, GitLab, or Bitbucket. In Netlify, create a new site by linking your repository and setting the build commands and publish directory for your project, typically npm run build and dist/, respectively. Netlify will automatically build and deploy your Vue app each time you push changes to your repository. No specific configuration file is necessary unless you need custom build steps or environment variables. Deploying to Vercel. Vercel is a cloud platform for static sites and serverless functions that fits perfectly with Vue.js applications. Deploying a Vue app to Vercel is straightforward thanks to its support for Git integrations and its powerful CLI. This explanation assumes you already have a Vue project ready for deployment and have Vercel CLI installed, npm i-g vercel. This simple command initializes the deployment process of your Vue application to Vercel directly from your project's root directory. When you run Vercel, the Vercel CLI automatically detects your project settings, prompts you to configure the project the first time, such as project name and whether to link to an existing project, and uploads your files. It then provides you with a live URL to access your deployed site. For subsequent deployments, simply running Vercel again will update your project on Vercel. This simplicity streamlines the deployment process, allowing you to focus on development. Continuous integration, continuous deployment, CI/CD for Vue apps. Continuous integration, continuous deployment streamlines the development process by automatically testing and deploying your Vue apps. A common tool for CI/CD with Vue apps is GitHub Actions. The following example shows how to set up a basic CI workflow using GitHub Actions, which builds and tests a Vue app every time a commit is pushed to the repository. This GitHub Actions workflow is triggered by any push event to the repository. It defines a single job named build that runs on the latest version of Ubuntu. The job consists of several steps: checking out the repository's code, setting up Node.js environment, specifically version 14, installing dependencies with npm install, running linting with npm run lint, building the project using npm run build, and finally running tests with npm test. This automation ensures that every change is tested and prevents the integration of breaking changes. Environment variables and modes. In Vue.js, environment variables and modes are critical for defining global variables that change depending on the environment the application is running in, development, production, etc. These variables allow you to set configurations that should not be hard-coded into your application's codebase, like API keys or endpoints, which might change based on the deployment environment. In the provided code example, Vue API app API URL is an environment variable set to a specific API endpoint. Environment variables prefixed with Vue app are automatically made available in the Vue application. Node env is used by Vue CLI under the hood to determine the mode the app is running in, which can affect things like logging and optimization. This setup allows developers to separate concerns and enhance security by not hard-coding sensitive information within the application code. Pre-rendering for SEO. Pre-rendering is a technique where a JavaScript website is rendered to a static HTML at build time. This makes the site more accessible to search engines and improves loading times. In the context of Vue applications, this can be achieved using tools like pre-render s-bar plugin with Webpack. The example below illustrates how to integrate pre-render spa plugin in a Vue project's webpack.config.js file. This code snippet imports the pre-render spa plugin and uses it within the Webpack configuration for a Vue project. Pre-render spa plugin is initialized with options specifying static dir, the directory where your compiled project resides, and routes, a list of routes to pre-render into static HTML. When Webpack runs, it generates static HTML files for each specified route, in addition to the usual JavaScript bundles. This process improves SEO by making content available to search engine crawlers that do not execute JavaScript, without changing the development experience or requiring a server-side rendering setup. Vue CLI Deep Dive. Vue CLI is a powerful tool designed to help you bootstrap and configure Vue.js projects efficiently. Let's dive into a simple example where we create a new Vue project using Vue CLI. The command Vue create my Vue app initiates the project creation process for a new Vue.js application named my Vue app. Vue CLI then prompts you to pick a preset. You can choose the default preset with a basic setup, or manually select features like Babel, TypeScript, Router, Vuex, CSS preprocessors, and linters. Once you've made your selections, Vue CLI sets up the project with all the specified configurations, dependencies, and boilerplate code, streamlining the project setup phase and allowing you to focus on development. Vue DevTools Advanced Usage. Vue DevTools is a powerful browser extension for debugging Vue applications. Beyond inspecting your app's component tree and state, it offers several advanced features that can significantly enhance your debugging capabilities. Let's delve into how to utilize one such feature. Time travel debugging. Time travel debugging in Vue DevTools allows you to jump to any state mutation that has occurred in your application. This is invaluable for understanding how state changes affect your app, and for pinpointing where things might have gone wrong. By selecting a specific mutation, Vue DevTools will revert your app's state to that point in time, making it easier to debug complex state changes. This feature becomes exceptionally useful in larger applications with many components and dynamic state changes. It's like having a powerful undo and redo system for your app state. Exploring Vue UI. Vue UI is a graphical user interface that helps you manage your Vue.js projects with ease. It provides a visual representation of project structure, dependencies, configuration, and task management. Vue UI is not a code-based tool, but a part of Vue's CLI package that can be launched by running the Vue UI command in your terminal. This launches a web-based UI in your default browser that offers a comprehensive overview of your project. You can create new projects, import existing ones, add plugins, run tasks like build or serve, and even manage project settings and dependencies through a user-friendly interface. Its goal is to make project management simpler and more accessible, especially for those who prefer graphical interfaces over command line operations. Integrating TypeScript in Vue. TypeScript provides static typing to JavaScript, which can help catch errors early through type checking. Integrating TypeScript with Vue enhances code quality and developer productivity. Here's a basic example of how to define a Vue component using TypeScript. In this example, we've imported Vue and a decorator component from the Vue class component package, which allows defining Vue components as classes. The myComponent class extends Vue, making it a Vue component. We've defined a property message of type string, initializing it with a greeting message. The mounted lifecycle hook then logs this message to the console. This setup demonstrates the basics of how TypeScript can be integrated into Vue components, allowing for type-safe properties and methods. Vue plugins. Vue plugins are reusable pieces of functionality that can extend or add global-level features to a Vue application. They can be used to add global methods, directives, options to components, or even to inject third-party libraries in a convenient way. In this code snippet, we first import Vue and the plugin we want to use, myPlugin. By calling Vue.use myPlugin SumOption true, we tell Vue to install this plugin into the Vue application. If the plugin takes options, those options can be passed as the second argument to Vue.use, which in this case is an object, SumOption true. During the installation process, the plugin will have a chance to add global methods, directives, component options, or perform other tasks to enhance the Vue application. Popular Vue.js libraries. In the Vue ecosystem, various libraries extend Vue's capabilities or provide additional utilities to improve development efficiency. Here, we'll look into Vuetify, Vuex, and Vue Router, three widely used libraries. Vuetify offers a vast array of ready-to-use material design components, easing the process of building a cohesive interface without extensive CSS. Vuex, Vue's own state management pattern, enables efficient management of application state throughout large-scale projects, ensuring predictability and maintainability. Vue Router facilitates the development of single-page applications by enabling client-side page navigation without page reloads, improving user experience. These libraries, while serving different purposes, collectively enhance Vue application development, streamlining the process and enriching functionality.